Hello friends, in this lecture we will learn about designing subnetworks, okay, and how blocks of address are allocated and the network admin or the ISP provided to its users, okay. So this is a very interesting topic that you are assigned a block of addresses and then you have to divide it into your network to assign it to your subnetwork, okay. So it's called kind of designing networks and subnetworks when you are allocated a block of IP addresses and you have to think about everything like how will routing happen properly, okay. So routing, how will you make subnets so that group of people have the same are on the same LAN and so on, okay. So these are quite important things, so we will look at it. So who assigns the block of addresses or IP addresses? It's ICANN, Internet Corporation of Assigned Names and Addresses, okay. And what it does, it allocates a block of IP address to an ISP, okay. So large block of address is assigned to an ISP to be distributed to the internet users, okay. And what happens, what are the criteria, okay. The first is that the requested number of blocks that you take should be a power of 2, okay. So when you are assigning number of addresses to someone, it should be a power of 2. Reason is simple, okay. So this small or lowercase n is the network prefix size and your n, which is your starting address of the network, okay. The number of blocks IP addresses in the network is this. So for your n to be an integer, okay, your this should be some integer, okay, and that is why and this n needs to be a power of 2. And then what happens is the number of requested addresses, and first it should be a power of 2. The requested block needs to be allocated, then of course it should be allocated such that there is an adequate number of contiguous address available in the address space, okay. So when you are starting your address in your LAN, writing your address to the first router, okay, or first computer, so for example 132.16.5.0, if this is the first address of your network /24, so what happens is you can have maximum of, for this network you can have 132.165.0, okay. So I have not given in fact 0.0, so you can have 0.255. this is the maximum you can have, okay. So it says that when and we want that, okay, allocated addresses should be contiguous so that you can basically route and make the subnets better, okay. The first address needs to be divisible by the number of addresses in the block. Next, what happens and what is the reason that the first address needs to be divisible by the number of addresses? The reason is the first address need to be the prefix, okay. The first address should be the prefix so that I can put all other bits in that as 0 after the prefix, and then also I can route, okay. So it means basically after the prefix, whatever are the values, the gateway router will have all those packets. So prefix followed by 32 minus n number of zeros, okay, needs to be prefix, okay. First address needs to be the prefix and after that you should have all zeros, okay. So it means it should be divisible by the number of addresses in the block. An ISP, so we will look with one example which will make our concept very clear about how address allocation is done. So let's look at the concept. Now an ISP is granted a block of addresses starting with 190.100.0.0/16, okay. So this is the starting address and it is giving all other IP addresses with /16. So this network is 190.100.0.0, okay, /16. It means what is the range of address? 190.100.0.0 to 190.100.255.255. So whole bunch of address in between is there. And how many addresses? So these slash 16 means it can have 2 to the power of 16 addresses inside that. And if you count all these addresses from 190.100.0.0 to 190.100.255.255, they will come to the same. The ISP needs to distribute these addresses to 3 groups. Okay, so now at first it has to give this address to 3 groups of customers. Okay, and what are they? So let's try to see. So here we have the first group has 64 customers. Okay, and each needs 256 addresses. Okay, so you should remember that the first group has 64 customers and each of them needs 256 addresses. So each of them, if they need 256 addresses, so in your host part there should be 8 bits. Okay, because to represent 256 addresses you need 8 bits. So here I need 8 bits for the host part, so 24 bit for the network prefix. The second group has 128 customers. Okay, and each of them need 128 addresses. 128 addresses means 7 bits for the host and 32 minus 7, which is 25 bits are for the prefix. The third group has 128 customers and each needs 64 addresses. So 64 addresses now means how much? So 64 addresses is 6 bits for your host and your 26 bits for the network. So let's design this network. Okay, design the sub block and find how many addresses are still available. So we need to design it, and we will, as an administrator or network designer, we want that okay, we should use the block as much as possible and allow contiguous memory. Okay, so let's try out. So this is the idea, but we will see first here what is there in group 1. Okay, so group 1, what was our need? This group has 256 addresses for each group. There are 256 addresses. The first thing is each group has 256 addresses, so 8 bits need to be there for the suffix length, or 8 bits should be there for the host part. So the prefix length will be 32 minus 8, it will be 24 addresses. Now our starting location was 190.100.0/24. Okay, so we had /16. Now I can divide it into subnetwork, so I start with /24. Okay, this is my first customer's first address. Then what happens? What will be his last address? So add 256 computers here, so it will be 0, 1, 2, 3 till 255. So last address is 190.100.0.255/24, which is written here. Now we need to have 256 such customers. So your last 8 bits will change and you will have 256 hosts. And if you change here these bits, okay, so this decimal part 0, 1, 2, 3 till 255, then you will have 256 such customers. So I will have 190.100.0.0/24 first customer's starting address. Next customer is 190.100.0. This will not be 0, it will be 1.0/24. The second customer, similarly the 256th customer is 190.100.255.0. okay, so which is here. Okay, in fact we have 64 such customers, so it will just go till 63.0/24. okay, so we are now done till here. So we are done with the first group of 64 customers, each of them requiring 256 hosts. So this is done. Okay, So first customer, second customer is this, third, the 64th customer is this. If it was 256 customers, this 63 would have gone till 255. So here, so we have 64 into 256 IP addresses are taken. Now, what is our next IP address that we can have? 63.255, till there we are taken. So now next address can start at 190.100.64.0. That can be my next address. So let's see that. So each group 2, we have 128 addresses for them, okay, and there are 128 such groups are there. So what we do, we need to have 7 bits in our network suffix to represent 128 hosts. What will happen now, we have 190.100.64.0 and now we have /25 network. This will go until 64.0 to 64.127. Okay, so this is my first customer. Next we can start from 127, still we have space for another 128, so it will be 64.128 till 64.255. This is the second customer. What will be my third customer? It will be 190.100. So it will be how much? 65.0/25, and this will go until 65. So it will go till 65.127/25. Then the fourth customer will be 190.100.66.0/25, and it will go till 66.127 will be the fourth one /25, the first address, and this will keep on going. Okay, and we need to have 128 such people. So after 64 till 127 we will have all the 128 address, because 64 will take care of 2 such groups, 65 will take care of the 2 such groups. So in 64, from 64 to 127 it will handle all the 128 groups. So this is done. So we have now the ending address 190.100.127.255. So next thing we can start is 190.128.0. This will be our next address. So let's see this. For this group 3, we want to have 64 addresses for each customer. So we can have 6 bits for the host. The prefix length is 26, and the groups there are 128 such groups. So I can start with 190.100.128.0, and because I have just 64 people, so it will be just add 64 to it. It will be 128.63, and we can cover in 128 itself. I can have 4 such groups. Okay, so I will have 128.0 till 128.63 first group, 128.64 to 128.127 the second group, 128.128 till 128.191 will be the third group, and 192 till 255 will be the fourth group. So something like this you need to do. So you have this is done. So we will have, finally we will go till 159. Okay, so here, because in 128 it has 4 group, 129 it has 4 groups, so till 159 if you go, so it will cover how much? So 159, so 160 minus 20, so it's 32 into 4, so it's 128 group it covers. So this way you can see that we have designed a network. Okay, our requirement was that we need to have three different types of group, and each group had different number of customers. Okay, so now we have designed till here, and still we have lot of addresses left, and we have used contiguous allocation so that we have a lot of addresses still left. So I hope you understand this. Thanks a lot.